with 1.1, and when I do the actual math class, I actually pull up the ebook, and I'll use the ebook to keep me kind of in line. All right, so we're going to go to main menu, and we're going to go to chapter contents, and the outline says that we're going to go through 1.1 through 1.4, and you should all have your outline in front of you for those 2 people that actually printed it out. And e-text. I had a student yesterday. I was going over MyLabs Plus, and I just covered, you know, the pretest and what happens when I do the pretest. I give you all the dates for the homework and the dates for the homework and the test. And I said, are there any questions about anything? And I had somebody ask me, how many tests do we have? I said, I have no idea. Why did I say that? What document do you have that tells you how many tests we have?
The outline.
Oh my gosh, Miss Lusk. How did you know that? All right, there we go. Statistics. Uppercase statistics. That's one of your first definitions that you need to learn. Let me go ahead and make it a little bit bigger, because Miss Dennis just gave me a cue that she needs to move up to see it. So I'm going to make it a little bit bigger for Miss Dennis.
No,
right, Miss Dennis? There we go. All right. Uppercase statistic. I'm not going to go with that. We're going to go with Hubert's definition. Write down uppercase statistic. Now, also something that I give y'all as an added bonus is I tell you when something is going to be on a standardized test. Now, some of y'all, that might help. Some of y'all are still in high school. Some of you will be taking the SAT and the ACT. But somebody name another test outside of high school that you might be taking in the future. Anybody? You probably don't know unless you're a college student already, but
the TEAS test and the entrance.
There you go. Miss Dennis just named one. The TEAS test, which is basically an entry exam for nursing students. What about if you go to Michelin? Are they going to give you a test? Yes. An employment test. What if you're going to graduate school when you graduate Clemson? Are you going to take a GRE test? Yes. So there are standardized tests outside of this class that you're going to be taking, and these words that I stress, like uppercase statistics, that's going to be on there. So what is uppercase statistics? The science of obtaining, calculating, and analyzing and interpreting data. And I think I spelled those words right, but if any spelling English majors are out there, please let me know when I misspell something. Okay. So that is the definition of statistics. Uppercase. Don't write anything. Don't get ahead of me, because that red you write down last. So don't get ahead of me. Now, statistics, the world of statistics revolves around 2 things. It revolves around the population and the sample. So it revolves around 2 things, the population and the sample. And the sample, when you get through with probability and statistics and you take several courses in probability and statistics, you will find out that the name of the game is to take the sample and predict for the population. But we'll get to that in just a minute. So write down population and sample. One of the reasons I try to use slides or pieces of paper from the previous class is my document cam has a little bit of a delay. So it kind of helps to have it already written. So that's why sometimes I use papers from previous classes, because that way it's not showing the lag when I'm writing. Now, with the population, which is always the biggest, it's always the biggest group. When you're talking about the population, you're going to be talking about parameters. And parameters are variables used in formulas for the population. Variables used in formulas for the population. I'm going to turn this off so it won't help with lag. Variables used in formulas, mathematical formulas for the population. Now, I did cut off for the population for a reason, so I'll get to that in just a minute. Variables used in formulas for the population, and they usually are Greek letters. And I'll give you two examples of Greek letters, mu and sigma. Now, sometimes mu is written like this, like that right there. Has the tail on the left. But when I was a student at Clemson, I put the tail on the right, and I kept doing it. So my mu technically is incorrect. This is the way that you write mu, with the long tail on the left. But anyway, mu and sigma. Sigma looks like an O with a pompadour on top. For those of you who know what a pompadour is, dang old hair poofed up in the front. Now, sample is always the smallest of the group. It's always the smallest of the group, and you're going to be dealing with lowercase statistics in the sample. And a lowercase statistic is the variables used in formulas for the sample. Lowercase statistic is variables used in formulas for the sample. And that is regular alphabet. That's the regular alphabet. A, B, C, D, E, F. And two that are used a lot are the average, which is, or the mean, which is X bar, and the standard deviation, which is S. So mu is the mean of the population, and this sigma is the standard deviation of the population. X bar is the mean of the sample, and S is the standard deviation for the sample. Now, why do you need to know this? Well, you need to know it for later courses, but let's say that you just take 120 and that's it. And you're sitting in a meeting, let's say you're working 2 or 3 years from now, you're working somewhere, and there's a department meeting, and in the department meeting, they talk about mu, sigma, X bar, and S. Now you know that these two have to deal with the population, and these two have to deal with the sample. And then you know that the sample is always the smaller of the two. Now, why do we deal with the sample and the population? Well, the population is usually what the business wants. Now, what does that mean? When you're in a business, or let's say AmMed or Fleur Daniel or Michelin, you're interested in the population, the people that you sell to. And you want to know things about the population. But you don't want to spend the two most important things in our lives. And what is that? It's right here.
Time and money.
You don't want to spend the time or the money to survey 10,000 people. So you hire somebody to use 1,000 people to predict for the 10,000. And that is this right here. That is why we have probability and statistics. and people that say, when are we ever going to use this stuff? Well, if you're just taking Math 120, chances are you'll just see it in a presentation. But if you take other probability and statistics courses later, then that might mean you might be doing this one day. Okay, if you take more than 2 or 3 probability and statistics courses in the future, that means you might be doing this either through a research project or for a dissertation or for a company. And that's called quality what?
Assurance.
Quality assurance. Quality assurance is a 25-cent word for probability and statistics in the application of that company. Taking data from the sample to predict for the population to save time and money. Now, I guarantee you some of y'all have sat through a whole semester of probability and statistics and you didn't know that was the whole point behind the whole class. Okay? Your main objective when you are a quality assurance person or a probability and statistics person is you're trying to take data from a sample and predict for the population. Whether it's for yourself, for a dissertation, or whether it's for a company and you're a quality assurance manager. That's the whole point behind probability and statistics. And this should be written down because all 3 of these concepts, statistics uppercase, population parameters, and sample statistics, those 3 concepts are on standardized tests, not to mention my test. Any questions on this?
No.
And let me know if everybody, is anybody not had enough time to write this down, hopefully? Anybody not? Okay. So let's go back to the handy dandy notebook. And that's what, now, after I explain what statistics is, you can go back and look at the definition the book gives you and say, okay, I understand it. Next page. If I cover something, that means it's important. If I don't cover something, that means it's not important. Oops, sorry. There's the definition of the population. The entire group. Okay. A sample is a subset. We already talked about that. Statistic is for the sample. Population, okay. Write down descriptive and inferential. Write those 2 definitions down. All you got to write down is consisting of organizing and summarizing data. And describes data through numerical summaries, tables, and graphs. You don't have to write down everything, but write down most of it. Inferential uses methods that take a result from a sample, extend it to the population, and measure the reliability. So go ahead and write down those 2, and I'll explain what that means. Give you a minute to write those 2 definitions down. Descriptive and inferential. All right, we got 22 and there are 24 in class. Good. Now, what is descriptive statistics? Well, descriptive statistics is when you find out something on your own information. let's say that you find your average for your test grades. That is descriptive statistics. You are organizing data and you are calculating it. What about if you go out and survey 100 people in the parking lot at Anderson campus on what's their favorite color? Then that would be descriptive statistics. Inferential is when you use, and this is kind of a general definition, is when you use other information and you predict. All right. When I ask people what their favorite color is, the 100 people in the parking lot, what their favorite color is, I'm not going to predict the next person will pick yellow. I'm not going to predict that. That's not descriptive. Descriptive is saying 30 people pick yellow, 20 people pick blue, 5 people pick red. That is descriptive statistics. Where are you at, Miss Dennis? That was a doo-doo. Are you at work?
In the closet.
Oh, you in your closet at work?
Mm-hmm.
Okay, bless your heart. But that's what happens to people that are weaned on a pickle. They get put in a closet in the end of the hallway where they work, and they don't talk to anybody. See, that's why you need to have a sense of humor, Miss Dennis. See where it puts you? All right, inferential. What is inferential? That's when you take, let's say you go to the highway department and you get the last 5 years of deaths by drunk drivers. That would be inferential. You crank it through and you try to predict how many people will die of drunk driving in 2021. That is inferential.
Say it again.
No, I'm not going to say it again.
Please.
When you take data from another source and you predict.
Okay.
That's basically what inferential is. Descriptive is finding data and analyzing it and interpreting. That's descriptive. Inferential is using someone else's data, not necessarily all the time, but mostly, using somebody else's data and predicting. That's extend it to the population and measure the reliability of the result. That's another word. That's a bunch of words for predicting. Now, I went over parameter. I'm not skipping it, but I've already went over it. There it is. Parameter, population. Sample, statistic. Parameter, population. Sample, statistic. They go together. Now, what is that noise? Where's that coming from?
It's me, sorry.
That's all right. I'm in
the Anderson campus.
Oh, okay.
In the
Are
lobby.
you at the Anderson campus?
Yeah.
Where are you sitting?
In the second story in the sitting area.
Oh, okay. Okay.
I'll turn the audio off.
No. That's fine. That's fine. I was just curious. I didn't know where it was coming from.
Yeah.
Let's see. Next page. Now, I'm not going to go over variables because y'all have been through math classes to get into this class. You have to have at least an Algebra 1. And you don't go through Algebra 1 or 101 and not know what variables are. There's letters used in mathematical formulas. I'm not going to go through that. Oh, yeah. This right here you will be tested on, so write it down. Quality, not what? What's the rule? Quality, not quantity. Qualitative, blondes, brunettes, redheads. Write that down. Qualitative, blondes, brunettes, redheads. What is blondes, brunettes, and redheads? What is that called? Starts with a C.
Category.
It is a what? Characteristic or a category? Write that down. Characteristic or a category. Qualitative. Category or characteristic. Another example. Brown eyes, blue eyes, green eyes. That is qualitative data. How do you know something is qualitative? Well, somebody give me the average of blondes, brunettes, and redheads. Why are y'all quiet? Give me the average of blondes, brunettes, and redheads. Somebody do that for me. What's wrong with that question?
Don't have enough information to answer it.
Well, no, it's not. No, it's not enough information. How do you take the average of blondes, brunettes, and redheads?
You look at the population.
Well, the answer, that's a good try, Jacob. But the answer is can't. You can't take blondes, brunettes, and redheads and get blondes. You can't take blondes, brunettes, and redheads and get an average of redheads. Okay, I tell you what. Somebody give me the average of zip codes.
You can't. There's a lot of different ones.
Because they don't have a mathematical what? Quantity. They don't have a mathematical quantity. Zip codes, area codes, social security numbers. That's all categorical because they do not have numerical value. If it lacks numerical value, it is qualitative. Write that down. Lack of numerical content. Lack of numerical content. Ask yourself, can you take the average of social security numbers? You could, but does the answer mean anything? No. So qualitative data, I would put mathematical and put a big X through it because you can't do mathematics with blondes, brunettes, and redheads. Now, I'm going to say Jacob. Like Jacob said, well, you would have to know the quantities. Now, if you knew the quantity, but think about it. 18, 20 plus 20 plus 20. Well, no, it'd be 20 plus 20 plus 10 probably, or 5 with the redheads. But 20 plus 20 plus 5 is 45. And 45 divided by 3 is what? 15? Okay, so 15 is the average. Somebody tell me that's the average of. I just took 20 blondes, 20 brunettes, and 5 redheads, and I added those up and divided by 3 and got 15. What is that? What is that the average of?
It's the average number per hair color.
Okay, you didn't say blondes, brunettes, or redheads. Why not? Because you can't. You can't say that 15 represents any of the categories. That's the point, okay? Versus if I had the average age of y'all, let's say the 9 people that are on the screen right now, and I averaged your ages, what would you say at the end of that? You would say the average what? That means I want y'all to talk.
The average age of.
The average age. Do you see what I'm saying? If you can say the average age or the average blank is blank, then that's quantitative. Let me go through and do it one more time. Blondes, brunettes, and redheads. 20, 20, and 5. You get the average of 15. What is that the average of? You can't say that's the average blank. But if I get the 9 people that are on the screen right now, that's Miss McAgina, Adams, Jacob, Simmons, Bash, Johnson, Lusk, Michelle, Dennis. And I add all those up and divide by 9. What have I just gotten? The average blank. the average age. If you can say the average blank, then you've got quantitative data. If you can't say the average blank, the average blonde, does that make any sense? No. The average brunette is 15. Doesn't make any sense. So when you're talking about qualitative data and quantitative data, quantitative is basically something you can take the average of. So let's do an experiment. This is where I ask for y'all to interact, okay? All right, so here we go. Mr. Adams, what is your zip code?
29627.
Oops. 29627. Miss Dennis, what is your zip code?
29625.
Where do you live, Miss Dennis?
Where you put that stupid Wendy's?
I told you I did not put that. I approved it. I did not put it.
So you put it there.
I got cussed out last month. I did. I got cussed out at the land use meeting. Man, I believe he was drunker than a nine-eyed goat before he came to the meeting. He just cussed all of us out.
When do you have those meetings and where? I'd like to come.
No, you ain't coming. I ain't letting you in. I'm gonna tell security that you have a gun. All right. Let's see, Mr. Michelle, what is your zip code?
29464.
There we go. I was looking for one of those. All right, let me go down here and ask some of these people that don't talk. Let's see. I'm gonna go with Miss Hernandez. What's your social security? What's your zip code?
29621.
Okay, and Miss Deese, what is your zip code?
29624.
29624. All right, there's 5 zip codes. Let's go ahead and let's get our handy dandy calculator out and let's take the average of those zip codes. So I'm going to take my handy dandy calculator, and where is it? I've only got 5 days. They're supposed to be buying me a permanent Smart View calculator. I only got 4 days left. I'll probably get it next week after my 4 days are out. 29627. Clear. 29627 plus 29625 plus 29464. Where is that, Mr. Michelle?
Charleston, South Carolina.
You didn't say it right, Mr. It's Charleston. You don't pronounce the R. It's Charleston. I'm kidding. That's what my grandmother used to say. Charleston. All right, 29624 plus, or I'm sorry, 29464, 29621 plus 29624. No 29626s? We don't have any 29626s in here. Okay, I was just curious. Equals divided by 5. All right, somebody tell me what that's the average of. $29592. Somebody tell me what that is. Somebody tell me what zip code that represents. 29592 is the average. Well, you can't say zip code because you don't even know if that exists.
Exactly.
You don't even know if 29592, you don't even know if that's even a place in South Carolina. That's how you tell if something is categorical, which means qualitative, or quantitative. Mr. Adams, how old are you?
17.
Okay. Miss Makujina, how old are you?
16.
Mr. Michelle, how old are you?
19.
Miss Hernandez, how old are you?
18.
And I'm 53. So let's take our handy dandy calculator and find the average. Now my age, of course, is going to throw it way off, but we'll get into that later. 17 plus 16 plus 19 plus 18 plus 53. I think I'm 53. When you're born in January and December, it screws up your head with your age. Anybody born in January or December?
My sister's born on New Year's.
Does she get confused about her dadgum age?
No.
I do.
I do.
I do.
I
still
do.
say I'm
When were you
14.
born?
December.
December is the worst month to be born in to figure out your age. I'm sorry. I'm always one off. Either I'm older 1 year, or I have to actually get a calculator and go, okay, 2021 minus 1966. Figure out how old I am.
I'm
And if
okay
you're not-
until I change age, and then I still think
What-
I'm like
what'd you say,
a year
Miss?
younger.
What'd you say, Miss Garcia?
I'm okay until I like change, and then I forget that I like grew a year or whatever.
Well, I'm gonna tell you something. When you're born in December, it's aggravating to keep up with. I don't know about January because I've never been born in January. But unless you're born in December, you have no idea what I'm talking about. So anyway, all right. So here we go. Divided by 5. And somebody tell me what that is. That's the average age. See, if you can say that's the average age or the average blank and understand it, then it's probably quantitative. If you say the average is brunette, that makes no sense. All right, so hopefully that helps you out.
24.6.
What'd you say?
24.6 is the average age, is what it is?
Average age, yeah, that's, well, of those 5, yes.
Oh.
Of those 5 ages right there. All right, 24.6. All right, now class started at what, 10:10? So that means it's over at what, 11 or 11:05? Somebody help me out.
11:05.
11:05.
11:05, I thought so. I just want to make sure I give myself a few minutes to call the roll and all that, because 23 people, I got to go down the roll. So anyway, let's go to the next thing. I want to get to discrete and continuous. There's 5 examples right there for you to put in your notebook. Gender, qualitative or quantitative? Somebody give me the average of female.
Qualitative.
There you go.
Qualitative.
Somebody give me the average temperature. What is that?
Quantitative.
Quantitative. Number of days in a week that that's college students study. Number of days.
Quantitative.
Quantitative.
Zip codes.
Qualitative.
Qualitative.
See? Piece of cake. All right. Now, I'm going to just get off of this because I'm going to ask you, I want you to get your calculators out. Everybody's got a calculator. Use the one on your phone. Use the one you got in front of you. Just get a calculator. This is simple math that we're fixing to do. And I'm going to show you the difference between discrete and continuous. Somebody tell me what 4 divided by 2 is.
2.
2. Somebody tell me what 3 divided by 2 is.
1.5.
1.5.
0.5. And somebody tell me what 1 divided by 6 is.
0.16. Repeating.
16666 blank. Okay. Now I want you, somebody tell me, somebody's got a calculator that'll do it. Tell me what pi is equal to.
3.14.
Well, I'm going to do it right. I'm going to do it for you. Pi second equals. Pi is equal to 3.1415926541. Somebody tell me what the square root of 2 is.
1.41421.
1.414213562 blank. And somebody tell me what the square root of 7 is. $2.645751311. Okay, now turn your calculators off. Somebody tell me what, I'm looking for my green highlighter. Okay, my son has been playing with my highlighters. I'm gonna go in there and beat him with a shoe. All right, somebody tell me what this digit is right here.
6.
I just highlighted this digit. What is that next digit beside the 6?
6.
6.
Okay, somebody said 6. Without any hesitation, somebody said 6. Is that true? Yes. So all of these you can predict or locate on a number line. All of these you can predict. What's this next digit right here? 0. What's this digit right here? 0. Now, give you a $100 bill. Nobody looking at a calculator. $100 bill if you can tell me the next digit of these 3 right here. Why'd you laugh? Why'd you laugh? $100 bill if you can tell me what goes beside that 4 without looking at a calculator. Beside that 2 and beside that 1. Somebody tell me.
3.
I'm not asking you to give me a number. I'm asking you to tell me without a doubt. Do you know that, Mr. Adams, without a doubt?
No, sir.
Why? Why can you not tell me what these digits are, but you were able to tell me what this digit was?
Nothing. Feeding line.
Oh. This have to do with discrete variable?
That's what we're doing, yeah.
Okay.
Give me time. Will you stop stealing my thunder, Miss Dennis? What does these have that these don't?
A pattern.
Pattern. Pattern, predict, locate is discrete. No pattern, not predictable. You cannot locate on a number line. Why can't you locate these 3 on a number line? Because these following digits don't stop, and you don't know what. You don't know what they are. So how can you locate pi when you don't know where these digits are, what these digits are? You can't. You can locate this because you know that it ends with a 0. You can locate this because you know that this next digit is a 0. You can locate this because you know eventually this digit will turn into a 7. That is the difference between discrete and continuous. Now, do you want to make it even simpler than that? And I don't know if I spelled that right. Discrete, you can count. How many eggs are in a dozen eggs? 12.
12.
You can count all day long, and all of you will get 12 when you count a dozen of eggs. Dozen eggs. But what if I ask you to measure the height of a tree? Well, half of you don't know how to read a ruler, so half of you would not be able to even tell me. All right? And then those of you that can read a ruler, will y'all all get the same height? No. Because measuring is interpreting. Measuring is interpreting. Let me ask you a question, females, because y'all fuss about this all the time, especially when you become married. Your scale in your bathroom weighs you, okay? You weigh on your scale in the bathroom. And you go to the doctor and you weigh. Which scale is wrong?
The doctors.
See there? Why? They're both scales. Why is the doctor's wrong?
Because I'm not naked.
What? Because you're not naked. Okay. Or it always, what does the doctor scale always do to you?
Make you bigger.
It makes you weigh more. Why? They're both scales. Why are they different? Because measuring is continuous. Measuring, you can't locate it, you can't predict it. What is measured? Somebody tell me what's measured. And I'll end with this. What's measured? Meters, liters, grams. What is meters? Distance. What is liters? Volume. What is grams? Weight. Height. You can also say distance is height. Meters, liters, grams. Those things are measured. And I will tell you this, the height of a tree, that is a test question on my test that people get wrong. So please write that down.
The height of a tree?
The height of a tree is continuous. All right. I'm going to shut down the recording. And I'm going to turn